Lesson 6.5, Graph Exponential and Logarithmic Functions. All right, exponential functions. We've already kind of talked about this in Lesson 2. Their graphs are always increasing. So it starts low, increase, and then it's very steep. So this is constantly bending up. And our basic function is y equals b to the x, some base, which is a positive number. That's not 1. But there's transformations. Since we use b for the base, I'm using a different letter for what we used b for before. In general, so y equals a, remember a was our vertical stretch, or if a is negative, it's a reflection over the x-axis. Our base to the c before this is what we called b. That c is our horizontal shrink, and the shrink is by 1 over c. The h is a horizontal shift, and the k is a vertical shift. Since it's shifting vertically, and notice we have this asymptote, which is a horizontal line. If we move everything up or down, we'll move that horizontal line up or down, which means a horizontal asymptote is y equals k. That's probably pretty important to know for our graph. So how are we going to graph exponential functions? Well, first of all, graph the horizontal asymptote. Oh wait, what was that? Remember, that was y equals k. Then you're going to make a table of values on your calculator. Going to plot the points and draw your curve. You do need to make sure the curve is near the asymptote at the edge of the graph. Notice over here on our graph is near the asymptote. Let's try page 320, number 17. We're going to describe the transformations and then graph the function. All right, so let's start with the transformations. What do we see? I see a negative in front. So that means our a is a negative 1. What? Isn't it a 2? No, the 2 is the base. The a is what's multiplied in front of the base. So it's a negative 1, which means it is reflected over the x-axis. What else do we see? We see this minus 3. So that was x minus h, so that means our h must be 3, which means it is a horizontal shift 3 to the right. And then graph the function. All right, to graph the function, I have to know the asymptote. So the asymptote is y equals k. Hey, wait, what was k up here? Remember, it's y equals a, b to the x minus h plus k. So what's added to the end? Nothing. Therefore, our asymptote is y equals 0, because k is 0. All right, so next I'm going to need my calculator, and I'm going to put it in for the function, and let's see, we don't need that one anymore, so it is negative 2 raised to the x minus 3. All right, and you can see our graph here kind of jumps down, but we're interested in looking at the table. So here's my table. I'm going to start by plotting my asymptote, which was y equals 0. And then when x is negative 6, y is essentially 0. When x is negative 5, y is really close to 0. Same with negative 4 and negative 3. negative 2. You can see the numbers are getting a little bit more negative though. Negative 1, we're almost to negative 0.1. 0 is negative 0.1. 1 is negative 0.25. 2 is negative 0.5. 3 is negative 1. 4 is negative 2. 5 is negative 4, and you can see, and then 6 is negative 8, which is off my graph. So we would draw that. All right, so you can see it's upside down, and from the original function of f of x equals 2 to the x, it has also shifted 3 to the right. Why don't you try this one? Pause while you work on it, and then I'll give you the answer. All right, for our transformations, the only thing we have is the 2. So that is a, since it's multiplied, it's a horizontal shrink by 1/2. So it's going to be half as wide. Again, there's plus nothing on our end. So our asymptote is also y equals 0, which we can graph. And then we'll need to make a table. So I'm going to go back to my functions. E to the 2x. If you want to see the graph, there it is. But again, I'm interested in the table. So notice the y value here is, in scientific notation, that means it's really, really close to 0. Same thing with the negative 5, the negative 4, the negative 3, you can see it's still close to 0. Same thing with the negative 2. The negative 1, we're at 0.1. 0, we're at 1. Then at 1, we're at 7, which is like up there. So you can see it was level and then went really steep. All right, those are exponential functions. But now we get logarithmic functions. So something like y equals log base b of x. And our b is some base other than 1. Remember, logarithms and exponentials are inverses, which means the x and y values are switched. So if a point, say, on our exponential is 1, 2, the point on the logarithm would be 2, 1. Which means graphically they're reflected over the line y equals x. So the line here, the graph there, that's the exponential. When reflected over the dotted line, you get the blue one, which is the logarithm. So every point is the same distance on the other side of this dotted line. All the points have switched their x and y values. So the horizontal asymptote, this one, of the exponential function becomes a vertical asymptote right here for the logarithm. Now here's where your calculator is likely to make a mistake. When you go to graph these on your calculator makes graphs by making a table, plotting the points, and drawing the curve, just like we do. However, your calculator isn't very smart. When it hits its last point, it stops, even though there may be more points. So your calculator might actually stop somewhere like there. and not do the rest of the graph. But the rest, it does continue down forever for a logarithm. Don't be fooled. So you'll need to graph the asymptote. So in general, our logarithmic functions are that, where we have the a, I'm calling it a c for now, an h, and a k. And they all mean the same thing. A is the vertical stretch. If a is negative, it's reflected over the x-axis. C, which are usually called b, is a horizontal shrink. And that shrink is by the reciprocal of c. H is a horizontal shift. K is a vertical shift. And here's the new thing. We now have a vertical asymptote. X equals h. That is very important. When you go to graph logarithmic functions, you need to first of all find and graph the, well, that should say vertical asymptote. Then you'll make a table of values. You might have to use the change of base formula to get your table of values. Let's say you're supposed to graph log base b of 2x. You go put that in your calculator as log of 2x divided by log of b. So the same thing. Plot your points, draw your curve, make sure your curve is near the asymptote at the edge of the graph. For example, let's try page 320, number 27. We're going to describe the transformations and graph the function. So I notice the negative in front there. So that means my a is -1, which means we have a reflection over the x-axis. I also notice this -7. That's the x minus h. So I know h is 7, which means we shift horizontally 7 to the right. Remember, the 1/5 is the base. That's not one of our transformations. So to graph, we're going to need to know the asymptote, and our asymptote is going to be x equals h. In this case, it's x equals 7. Now notice on my grid here, I don't have an axis, so I need to put one in. So we'll make that the x-axis. And looking at my graph, I'm going to make this the y-axis, and I know to do this because I've done the problem before. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. X equals 7 is the asymptote. So I'm going to put that in as a dotted line. And then we're going to need to make a table. So I'm going to pull out my calculator. I'm going to enter a function, so it's negative. I'm going to use the change of base formula. So it's log of the big stuff, and then parentheses, the x minus 7, divided by log of the base. If you look at the graph, there it is. Nice. Notice it goes down. If I go to the table, what? We have all these undefineds. Yeah. You can't take logarithms of a negative number. And remember, it's still negative until we pass the 7. So we have 8, 0, 9 and 0.4, 10 and 0.6, 11 and 0.9, 12 and 1, 13 and 1.1, 14 and 1.2, 15 and 1.3. It's just going to keep going up very slowly. But it really doesn't take much time to actually plot the points. And look at that, now I'm out of graph. So I think we probably have this part understood pretty well. But then what? Well, it dives down next to the asymptote, so you have to have that part on your graph also. Goes all the way down to the bottom of the graph near the asymptote. Now why don't you try number 25? Pause. All right, so I see we have A. So I see the A is a 3, which means it's a vertical stretch by a factor of 3. Now, notice the x minus 5, this bit here. It is not in parentheses. When it's not in parentheses, that minus 5 is the k. To be h, it has to be in parentheses with the x. So that's our k. So that means we're going to shift down 5. All right, to graph it, we need the asymptote. Our asymptote is x minus 8, or x equals h. This time there is nothing in parentheses with the x, therefore our h must be 0. So our asymptote is there, and then we'll need a table. Okay, we'll add the function 3, and I'm going to put this in as a change of base formula, so it's log of the big thing. Remember, though, only the x is in the logarithm, not the 5. Divided by log of our base, and then minus 5 at the end because it's not part of any of the logarithm. That's what our graph will look like. And there's our table. Again, it's undefined when the input is 0 or less. It's negative. All right, so we have 1 and negative 5, 2 and negative 3.5, 3 and negative 2.6, 4 and negative 2, 5 and negative 1.5, 6 and negative 1.2. So it looks like it's curving like that in the bottom corner of our graph. Last thing in this lesson is how to find the inverse. Since exponential functions and logarithms are inverses, we can just rewrite one as the other, and then it's the inverse. So to find the inverse, you isolate the logarithm part or the exponential part, then you switch the x and y, and then you rewrite it as the other. It's an exponential or a logarithm. So try page 313, number 47. Let's use that as our example. Notice this logarithm part is already isolated. I can't move the 1 because it's in parentheses inside the logarithm. So we'll switch the x and the y. All the y's become x's and all the x's become y's. And then we'll rewrite it as an exponential. Remember, we had if it was log base b of y equals x, that was the same as b to the x equals y. It's from several lessons back. All right, b was the base, but what's the base here? That's right, you remembered. ln, the base is e. So that's our base. And conveniently equals x. So it is. That's our exponent. So it's e to the x equals the other part, which is the y minus 1. So then we just add 1, so it's y equals e to the x plus 1. Why don't you try number 51? Pause the video while you do it. All right, your answer should be y equals log base 5 of x minus 9. You would add the 9, switch the x and the y, and rewrite it as a logarithm.